Hello everyone. Today we'll be looking over the Fourth Industrial Revolution. We have separated this presentation into three equal parts. I will be focusing on the past, John will be focusing on the present, and Max and Charles will be focusing on the future. Let's start with the past. Beginning topic 1, I will be looking over the first three industrial revolutions. Starting with the first industrial revolution, it began in the late 18th century in Great Britain and continued until the early 19th century. This revolution was the beginning of major societal changes, especially for the economy, as people began creating new inventions which would launch society from rural into industrial environments. The most notable invention of this era would be the steam engine, which had many applications enabling quicker production and quicker travel. The second industrial revolution is known for its introduction of electricity and the utilization of steel. Beginning in the mid-19th century and lasting until the early 20th century, this era is notable for the introduction of mass production and its advancements in communication and transportation. This, of course, was made possible with certain inventions such as the telephone, the radio, and etc. Last but not least, we have the third industrial revolution. This is also known as the digital age and is defined as the introduction of electronics. With the invention of the transistor, a device used to control and amplify electrical signals, other inventions were developed, such as the computer, the internet, and etc. Now on to today's topic, the Fourth Industrial Revolution. The term Industry 4.0 was introduced in 2011, but the term the Fourth Industrial Revolution was officially coined in 2016 by the founder of the World Economic Forum, Klaus Schwab. But what does the Fourth Industrial Revolution really mean? Well, it revolves around the fusion of electronics with the real world, or as it is defined, quote-unquote, the blurring of boundaries between the physical, digital, and biological worlds. In other words, different tech today can make real-world analyses, which can be applied as a response to real-world situations. One example I found was the usage of 3D imaging and stem cells to recreate someone's bone structure, which allowed for new methods of study on bone disease. Some examples of tech include AI, the Internet of Things, 3D printing, and as previously mentioned, genetic engineering. The Fourth Industrial Revolution has been quite a controversial topic with economists. Many believe that rather it being its own revolution, that it is a continuation of the Third Industrial Revolution. Although both industrial revolutions do share similarity in terms of their usage with electronics, they do have differences in terms of their technology. The Third Industrial Revolution had technology meant to automate processes solely in the digital realm, while the technology in the Fourth Industrial Revolution aims to interconnect the physical, cyber, and biological realms together. Tech in the Fourth Industrial Revolution analyzes real-time data and adapts depending on the different tasks. The ability to analyze real-world problems isn't the only thing this technology can do, however. It can also be said that this technology can be self-sustainable, meaning there can be little to no human oversight while it can still function. This was unattainable with the technology in the Third Industrial Revolution, and to take it a step further, especially the second and the first. Now on to Jonathan, who will tell you all about the Fourth Industrial Revolution in the present day.
So, coming up on the present, I want to discuss what's been happening in the past couple of years up until now. But before I get into the current economic landscape, I want to go into the weeds a little bit and talk about some current technologies that are defining 4.0 presently. These are technologies like cloud, Internet of Things, advanced robotics, and more. However, these three are trumped by one to stand above all, that being large language models, the new hyper-intelligent and generative AI models. There's a strong argument to be made, at least at present, that LLMs are the main production factor of the Fourth Industrial Revolution, since they synergize with all these other technologies to create value. For example, cloud computing provides the infrastructure for AI, IoT supplies the data to feed AI models, and robotics uses AI to operate intelligently. Essentially, it's the scale and generative capacity of LLMs that have made them the pinnacle of Industry 4.0. Now that we're out of the technical weeds, let's look at how LLMs have impacted the world economic landscape recently. Between 2023 and 2025, there's been a surge of investment into AI from venture capital, governments, and large tech firms. Global VC funding in AI jumped from $86.3 billion USD in 2023 to $131.5 billion USD in 2024. Furthermore, global deal value of AI rose from 24.7% to 35.7% from 23 to 24 as well, clearly showing signs of a significant rise in investor confidence and financial interest in AI. In March of 2025, our own Canadian government put 240 million Canadian into Cohere Inc., a Canadian-founded AI company. This was part of its 725 million Canadian project to build domestic AI centers here in Canada. Finally, for big tech, Microsoft is a great example. In January, Microsoft sunk 80 billion USD to fund the building of its own AI-enabled data centers. These three major players clearly see the current and future value of LLMs in the industry and Industry 4.0. For businesses, GenAI's ability to intelligently generate text, images, and code has significantly streamlined workflows. As you can see from the stats under the Business Boosts section, AI brings a significant boost to some critical key performance indicators. On the macroeconomic scale, the quest for even better AI models has influenced major spending not only in AI data centers, but also the adjacent 4IR technologies like semiconductors and automation. This, in turn, indirectly supports GDP growth through higher efficiency and innovation. Collectively, these technologies lower costs, boost productivity, and fuel enhanced innovation. This has the end product of driving significant growth and reinforcing the broader economy. So just to illustrate my point here, I have this diagram from 2023, and you can see that there's already a lot of adoption of AI in these different corporate functions, specifically for things like analysis. Now, new technologies always bring downsides, and AI is obviously no exception. Currently, analysts warn of an AI investment bubble reminiscent of the 2000 dot-com era, marked by hype, inflated valuations, and unclear profitability. Major firms like OpenAI are burning through billions on data centers and compute without sustainable revenue, which is raising fears of a market correction. Meanwhile, automation has displaced some white-collar jobs, creating short-term job instability even as new AI roles emerge. And despite the benefits, AI's economic toll is also heavy, with data centers, IoT, and chip manufacturing consuming vast energy and resources. And finally, high costs and limited access to infrastructure have left big tech firms with a near total control over the AI industry, so essentially a monopoly. And now, what's next? So while Industry 4.0 is more than just LLMs, my goal with this section was to highlight how important Gen AI is to the 4IR in current day.
Now that we've thoroughly covered the present, we can move on to how it affects the future. We've seen that the fourth industrial revolution promises unmatched productivity, but for economists, we must ask, what is the cost to our most vital resource, human capital? We face a critical trade-off, short-term gains versus long-term cognitive ability. A recent MIT Media Lab EEG study on students revealed the danger. Researchers found that ChatGPT users showed the lowest neural connectivity in brain regions tied to executive control and memory. The mechanism is cognitive offloading. Students simply copied and pasted and consequently failed to recall the content they produced. This is where the economic cost emerges. If students rely on AI to bypass learning, the investment in education yields workers with diminished analytical skills. This means lower return on investment for education, a critical decline in the quality of labor factor needed for complex modern economies. To fully realize the fourth industrial revolution's potential without sacrificing our workforce, policy must mandate AI complementarity, using AI to aid critical thinking rather than allowing AI replacement which bypasses it. We must actively protect the quality of our labor factor.
One of the key forces of the fourth industrial revolution is driving economic growth, but is also changing how income is distributed between labor and capital. AI is transforming production, much like steam engines or electricity once did. It automates complex mental tasks, things like writing code, optimizing logistics, and analyzing data, as well as creative design, by allowing companies to produce more with fewer resources. A 2024 report from the OECD finds that artificial intelligence could raise global productivity growth by 1% annually over the next decade. That's roughly the same boost electricity gave during the second industrial revolution. The reason is simple. AI helps businesses make faster, smarter decisions while reducing costs, increasing total output across almost every industry. But the real economic question isn't whether AI creates growth, it's who benefits from that growth. Running large AI systems demands enormous computing power, vast amount of data, and advanced infrastructure, because only a few corporations can afford these investments, ownership, and therefore the rewards. This becomes concentrated in their hands. As a result, profits flow mainly to shareholders and investors rather than to the workers who help operate these systems. Recent research from the MINITI, studying European regions, found that when regional AI innovation doubled, the labor share of income fell about 1%, meaning that a smaller slice of national income went to wages while a larger share went to profits and dividends. This trend, known in economics as capital deepening, shows how automation can raise productivity but shifts income towards capital owners. This creates a winner-takes-most dynamic. A few firms with data, scale, and algorithms dominate entire industries, while many workers experience stagnant wages or job displacement. In other words, AI is amplifying inequality even as it grows the economy. The challenge moving forward is ensuring that AI's productivity gains are shared broadly. Policymakers could respond with profit-sharing models, retaining programs, or taxation on automation profits, ensuring that growth doesn't come at the expense of fairness. To sum up, AI is fueling the next wave of global economic expansion, but it is also rewriting the social contract between capital and labor. If the last three industrial revolutions lifted the middle class, this one risks widening that gap, unless we design a system that lets everyone rise with the machines and not be replaced by them.